Hi, welcome to the part 2 of this video series where we are covering Azure DP 200 important questions for the exam. The key in these videos are the explanations that are provided for each and every option of the questions. I would request you to subscribe to my channel, like my videos, and if you have some constructive comments, then please drop your comments. Let's jump to question number 12. For questions 1 to 11, please refer the part 1 of this video series. I would request you to pause the video here in case if you want some more time to read the question. Our first task would be to identify what are the keywords in these questions. So let's delve deep into identifying the keywords for this question. So if you have read the question carefully, you must have seen these are the keywords here, and we have 6 options provided, out of which we have to choose 3 technologies. So basically, which of these options would provide high availability without any performance degradation? So if you see the options, there are 2 options which are referring to the availability model. So first let's understand what are these availability models. So let's first look at the standard availability model. In this model, the compute and the storage are divided. So the storage has high availability, but the compute does not. And hence, there will be some performance impact if you have highly business critical applications where high availability is absolutely a need. Then you cannot use this model because it will compromise your availability. Since this question is asking about a mission critical application, so option C cannot be an answer. Hence, we will strike off option C. Now let's look at option A, premium availability model. Now, premium availability model, this is divided in a cluster model. It has different nodes, and there is a synchronous replication happening across the nodes. Always remember, a cluster-based architecture is used for critical workloads. That is what exactly our question is asking for, and it has minimal performance impact during maintenance windows, and it provides a very high IO. Since our question is talking about mission critical application and it does not want a performance degradation during maintenance windows, and hence premium availability model would be our first answer. So we will mark this answer and proceed forward. So let's look at option D, SQL data sync. Now SQL data sync, the use cases for this is if you have an on-premise database and if you want to sync it up with another SQL database which is either on premises or on Azure SQL Server, then you can use it. It provides bidirectional syncing. So basically this won't give you high availability. It is just used to sync databases. Another use case is where you have a website and this website is having very large load, so this database is handling those large loads. But you also have a requirement where you have a reporting app. Okay, so you have a reporting app and you don't want to load this database. So what you can do is you can split this functionality. You can create another database and use a SQL data sync. It can be unidirectional, it can be bidirectional if there is a need. Since it's a reporting app, and most likely you'll be reading it, so a unidirectional sync would help. So this is another use case. The third use case is where you want to do a globally distributed app. For example, you have the database in US and you have your customer base in Bangalore, and if Bangalore users want to access the US database, there are latency issues. So what you can do is you can create a database in India. You can do a sync up and you can do a bidirectional sync up as well, and then you point these users to the database in India. So what is the problem you are addressing here? You're not addressing high availability, you are addressing network latency. So how have we addressed that? So people who are in Bangalore, they are accessing the database that is close to them. US database would be far off, so you are accessing a database which is close. and this is how you're addressing the network latency issue. Now, few things is very important for data sync perspective. First is the service is available across all regions. You need to have a DB account. You can sync databases in different subscriptions. You can sync across clouds like Azure Public or Azure China 21 ViaNet. You can sync these two databases in two different clouds. So please remember, you should not use this mechanism for backup and restore, because syncs are not going to version your data. And in order to monitor the syncs, you should use an Azure monitor log. This will help you monitor the syncs. So if we come back to our question, it is asking about high availability, and the data sync is not giving you high availability, but it is addressing the network latency issues. So hence option D is wrong in this perspective. Now let's look at option E, which says always on availability groups. So suppose you have an availability group and you have different databases in that group. So this box is a group, and you have, suppose in this is an example of an insurance related database or databases, and you have a claims processing database, you have a payments database, customers database, contacts, and subrogation. Now what happens if this database goes off, just the payments database goes off? So it doesn't make sense just to fail over just this database and then use other databases from this group. So in case of a failover, uh, what happens here is, this entire set of group would be failover to this group. So all databases will fail over here, and uh, this mechanism has one primary replica and 8 secondary replica for each databases. So this is designed for high availability. So the question is totally linked to high availability for mission critical applications, and always on AZ availability groups AG would suffice this purpose. So we get our second answer, and we need one more because it's talking about 3 technologies. Now let's jump into option B, which is virtual machine scale sets. So now it is important to understand what is a scale set. A scale set is just like a virtual machine. Is a virtual machine, and in terms of AWS world, if you see Amazon, this is your EC2 instance in terms of AWS. Now the main purpose of scale sets is twofold. First is it provides you elasticity. Suppose the workload on this VM increases, so what happens is you can spawn multiple VMs. If you can spawn one more, and if you think that these two are not sufficient and the load is increasing, you can spawn 2 more. Okay, so this is what the scale set does. It does this scale out dynamically. Okay, but our question is asking Azure SQL database. So Azure SQL database does not exist on VM. If you see the SQL server that is supported on a VM, if you have licenses on premises and you don't want to pay, you don't want to throw that, and you want to use it in your cloud world when you migrate to cloud. So if you have software assurance, you can use Azure hybrid benefit, so that you can reuse the same licenses, same SQL server, and deploy it on your VM. Our question here is very specific to Azure SQL database. Azure SQL database does not reside on VM, and hence scale sets will not help with high availability. So hence we are striking off option B. Now let's quickly look at option F. That is the only option that is left now, and we have to choose 3, so this should be our answer. But let's look at zone redundant configuration. So what happens is, in order to provide high availability, suppose you are in a single region and you have a single AZ deployment of your Azure SQL database. Now if this fails, you lose connection, and your high availability is compromised. Now the question says it's a mission critical application, so you cannot afford that downtime. Hence, you can choose a zone redundant configuration. What it does is you deploy this Azure SQL database in multiple AZs. Suppose in a region there are 3 AZs, you deploy it in all 3 AZs. So if AZ1, this data center fails, okay, then your application can still work on this data center and this data center. So that way, the downtime will not be there, and this is absolutely must for a highly business critical application. So we get option F. This is our third answer. So here we get our all 3 answers. We lock this. A, E and F are the right answers. Now before we move to the next question, is very important for us to understand how does the SQL data sync work. So these are some extra tips or extra concepts. So the data sync, it has a hub database and a member database. Your member database can be on premises or can be on cloud, but the hub database has to be on cloud, and this is how the sync up happens bi-direction. And this is the second configuration where you have the sync up happening between 3 or more databases. So the sync up always happens between hub databases and member databases. So in this case, this member database is on Azure and this member database is on premises. One more important concept here is the consistency. So SQL data sync provides eventual consistency. That means that it is not strongly consistent. If any insert happens here, that insert would not happen immediately here. It eventually would happen. How it works is, the data sync works is, if there are insert, update or delete operations, so there are triggers being set and a user table is created for each of these inserts, updates and deletes, and then that is eventually synced up with the member databases. This is how the syncing happens, and hence the syncing is eventually consistent. It is not strongly consistent. What a strongly consistent means is, if the insert happens here, and if I put a select query here, I can see that data. If I put a select query there, I can see that data same, and that even if there is, it would happen at the same time. It would be strongly consistent. But with the eventual consistent, if I insert a data here, I put a select query here, I can see the data here. But if I put a select query here, I cannot see the data. But say after 15 minutes, if I come and fire this query, now I can see the data here. So it is eventually consistent. So this section explains why data sync should not be used for these scenarios. Disaster recovery. So Azure geo redundant backup should be used for disaster recovery. Like we explained, like geo redundant configuration, what it does is, if one AZ fails, this is your disaster strikes, AZ1 fails, then AZ2 or AZ3, your application will route to AZ2 or AZ3, and that is the right mechanism for disaster recovery. Data sync should not be used for disaster recovery. The second stuff is, if you have any read-only replicas to load balance read-only query workloads, so you should not use for read for creating a separate schema for reads. You should use read replicas. So this is what is recommended. Use read replicas for read scaling. And third is for ETL, any kind of data movement where from one system to other system you are transforming and moving the data. We should use data factory, or this is SQL Server integration services. This is the built-in Microsoft ETL for on-premises that we used to use. In the cloud world, we can use Azure Data Factory. And the fourth one is for one-time data migration between your on-premises SQL Server and Azure SQL database. We should use the data migration service, okay, the first time. And henceforth, like if there is a need that your on-premises server will still be on, if it is not decommissioned, then the regular sync ups can happen using SQL data sync. But the first migration, the one-time migration, the first migration should happen through data migration services. Now let's see question number 13. Please pause the video here if you need some more time to read this question. Please focus on the keywords. I have marked the keywords, but you can read and identify the keywords yourself. So here it is clear that the question is related to file storage, and they need a single storage account for all read, write, and deletes. And the second requirement is they want a retention of the on-premises copy of historical operations. So whatever on-premises copy they want to move it to the Azure storage, and the Azure storage should be good enough to hold these on-premises copy. Now we need two actions to identify two actions from these five options. Let's look at the options. The options are categorized into two types. The first type is option where options A, C, and E are similar, where the only difference we see here is the service type. The first one is blob, table, and the queue, and the second type is options B and D, where they are trying to tell you which tool they will use to copy from on-premises to cloud for this requirement, the retention of on-premises copy. So to copy, they are having two options: AZ copy, and then the next copy is storage client. Now let's quickly understand what are the different storage types. So these are the different storage types: blobs, files, queues, tables, and disks. Now the question is talking about file storage, but in this case, if you see, these three options do not have file storage. So blob is capable of holding the files as well. So blob seems to be more appropriate, but let's try to understand what each option means. So blob should be used for text and binary data. This is also good for your big data datasets. Now in this case, files are usually text or binary formats, so it would qualify under blobs. But let's look at others. So files refer to managed file shares. This can be on premises as well as on cloud. If you require messaging between components, then queues are better. It holds the messages and in a sequence, etc. So that is a different type of storage. Tables are used for NoSQLs, where you have schema-less databases, etc. So those will go in tables. And disks, as you know, if you are coming from the Amazon world, you have EBS, Elastic Block Store. So disks are the block store in the Azure world. Now if you see the question, it's talking about file storage. So files would usually get classified under blob. It cannot get classified under table because tables are related to NoSQL, and it cannot get classified under queues as well because queues are mostly related to messaging data. Hence you get your first answer here, and the moment you get your first answer, you have also struck off two options, because this is the best way to group the options. This technique will help you answer the questions in the exam in time and complete all these questions before time. Now this option just addresses the first question, that is a single storage account. Now the second question, retention of an on-premises copy of historical operations. So in order to retain it, you will have to copy it to cloud environment. So right now you're on premises and you have to copy it into cloud. So the best tool to copy it into cloud from on premises is always AZ copy. Now AZ copy is a command line utility. It only works for files and blobs. It doesn't work for queues and tables. It works for files and blobs. So in this case, it is perfectly suited for us. The question doesn't classify the operating system, but it works, this AZ copy tool, it works on Windows, Linux, and Mac OS platforms. It supports both 32-bit as well as 64-bit Windows platforms, and it is tightly integrated with Active Directory or SAS tokens. Because if that authentication is not done, then how would you start your data moves? Now, storage client. Storage client is just a library. You can use it from your desktop or laptops, etc. And this is usually used, if you want to call a library for some purposes. This is usually not used for copying from on-premises to cloud. The best tool to copy from on-premises to cloud is AZ copy. Hence, we get our two answers. We will lock options A and B as our final answers. Now let's switch to question number 14. So you may pause this video to read the question carefully. I have marked the keywords here. You can read this question and identify your own keywords. So basically you have a Cosmos DB implementation. The data is partitioned in containers. The containers are configured separately, and the data must be accessible from applications hosted around the world. Minimum latency. So these two are very important. The data should be accessed across around the world, and the solution must have minimized latency. Now let's look at the options quickly. There are 5 options and we have to choose one answer. So in this case, the first one is, if you see, options A and option C are similar, but one is account level throughput and the other is table level throughput. Both are wrong because the throughputs are at the database level and at the container level. Let's look at the throughputs. In Cosmos DB, we have provisioned throughput. The provisioned throughput is at the container level and at the database level, and they can be set manually or they can be set automatically. Now, if you are setting the throughput at the container level, each container will have specific configurations, and Cosmos DB provides SLAs for those configurations. If it is those configurations or those parameters are not met, there are penalties that Azure would pay to the customer. So these configurations apply at the container level. The amount of space, RAM, and etc. will be applied at the container level. Now, if you have it at the database level, so database would have multiple containers. So if you are provisioning the throughput at the database level, then if there are multiple containers, the containers will have to share those throughputs. Now, the which container will use how much throughput will also depend upon the total number of containers available, the partition key, and distribution of the workloads across the containers. So these options A and C are wrong. We will strike this off. Now let's look at option D. Option D is wrong because in this case you are doing a manual addition of the regions to the Azure Cosmos DB, and manual addition with Cosmos DB, nothing should be done manually. You should set automatic options here. And the second reason why this option is wrong is because it is saying that the data would be replicated globally manually. So you would never meet this minimized latency requirement. So hence D is striked off. Now let's look at option B. Option B is talking about geo redundancy. So first, it is both these options B and E are talking about table API, because here we are talking about key value pair. So Azure Cosmos DB is a if you're talking about key value pair, then we are talking about table API. Now let's quickly look at geo redundancy. So the geo redundancy option, in this case, for example, you have a set of users who are accessing the database, the Cosmos DB in US East, and a disaster strikes, and for some reason this data center goes off where the Cosmos DB was hosted. So what happens then? So the next thing that would happen is this would go away and the users would be connected to the US West. So this is your geo redundancy. You have the same database in multiple geos, and this is a solution for disaster recovery. This is not a solution for low latency. Always remember that. Hence, we will strike off option B. So option B is striked off, and this leaves us only with option E. So option E is correct. In this case, we are enabling multi-region writes. With multi-region writes, what happens is you will be meeting your minimized latency requirements, and the data can be accessed across the globe as well. So in this case, in this question, what will happen is if you have a set of users, so for US East you have a different set of users, for US West you have a different set of users. You have the same database, put both the places, and the with enabling writes for each region. So this will provide you a low latency because the users in this region would have entered the data, and when they try to fire select queries, they will immediately see that data, and the latency will also be low because it's close to them. Now in this case, the users who are in US East, if they write their own data here and when they try to read it, it will give them lowest latency, and the data will be consistent as well. Okay, so multi-region writes are useful here. Now in this case, though the question doesn't give us this option, but the ideal option would have been that you do a single region write, and then you have read replicas across all the regions. But in this case, since they have given multi-region writes, this is the right option. So we will lock our answer here. Option E is the right answer. Let's move to the next question. Let's look at question number 15. So this is a question, and you can pause the video here if you want to read this question in leisure. First, try to identify the keywords. So I hope by now you must have read the question and identified the keywords. I'll explain this question in terms of a diagram. So basically the question says they have a SQL Server instance on premises installed in a VM, and this needs to be migrated to Azure SQL database on cloud. Now they also have an Active Directory in premises, and they want to migrate that to your Windows Azure Active Directory on cloud. Now the question says is they need to configure Azure SQL database to use an Azure AD user as an administrator. So let us go through the concept first. So this is what is happening. In your cloud box, you will have an Azure SQL database, and you will have a Windows Azure Active Directory. This is what you have. So in this case, usually what we do is we create two admin level accounts, one at the server level admin account at the database. So this is not a database level, this is a server level. So we create this admin account on the server which is hosting Azure SQL database. Then the next is we create an admin account and an Azure AD account. So these are the two standard steps so that your SQL database can talk to Azure AD. So the key here is you should set this at the server level and not at the database level. This is the key. Now let's switch back to the question. So this is the question, and if you see the options here, uh, if you see option A and option D, both are similar. So there are all these options are split into two groups. Options A and D are talking about access control, and options B and C are talking about AD being set as an administrator. So we should use access control if you are trying to give a RBAC, that is a role-based access control to certain resources or groups of resources on Azure cloud. Here you want to set AD as an administrator, so the option should have AD and not access control. Hence, we would strike off options A and D. Let's look at option B. So if you see between options B and C, C is wrong because C is asking you to set this admin role at the database level, and we have to set it up as at the server level, like we saw in our slides. So on this slide, it should be always set at the server level and not at the database level. This is the key. So I'll take you to the documentation of Azure, and here you see it is always set at each server in Azure which hosts SQL database or Azure Synapse. And that's the first thing that you do is you create a single server admin account, that is the administrator of the entire server, not the database, of the entire server. The second thing you do is create a second admin account as an Azure AD account. Okay, and this principle, this stuff that you created, is used as a contained database user for the master database. So we will lock our answer. Option B is the final answer. So this brings us to the end of this video. I'll upload some more parts. Stay tuned, and I request you to subscribe to my channel, like my videos, and if you have comments, then please drop in.